Okay. Guys, we are required. Guys, excuse me. Ladies and gentlemen, we are live, so please stay quiet because your talking is going to be recorded. And if I don't like what is heard, I'm just going to leave the video. So let's just get started. Please don't talk. Okay, so we're on properties of parallelograms. First, let's take some parallelogram notes. We know a couple of things about parallelograms. Technically, we know 5 things. The first thing that we know is we know that the opposite sides are congruent. So if you have a parallelogram, we know that this side and this side are equal, and the 2 shorter sides are equal. That's true for every parallelogram. Now, there's special things about rhombuses. Rhombuses, all the sides are the same, and the diagonals are perpendicular. There's special things about rectangles. Rectangles have right angles. Special things about squares. Remember, squares, rectangles and rhombuses got together and had a baby. But with a parallelogram, always the opposite sides are congruent. The other thing that we know is the opposite angles are congruent. And when I say opposite angles, I mean that the corner, the opposite corner. So literally, you'd have to walk across the entire parallelogram in order for you to have the angles to be congruent. We also know that the consecutive side or consecutive angles equal 180 degrees. And remember, that kind of comes from if I extended these lines and their parallelogram into parallel lines, and I had this be a transversal, this angle right here and this angle right here would be consecutive interior angles. Remember that from Unit 2A. So because they're between 2 parallel lines on the same side, that means that the sum of their measures are 180 degrees. The other things that we know are the opposite sides are parallel. And that's really where the name parallel comes from. It means that this side here, this long side, is parallel to this side. They'll never touch. Their slopes are the same. And this side right here and this side right here are parallel and will never touch. Sir?
For number 2?
Yes, sir.
Where is that next to?
Opposite angles are congruent.
Okay.
And then the last one is that the diagonals of a parallelogram bisect each other. So basically, if you have a parallelogram like this, wherever they cross, they split them up into 2 equal measures. So, for example, where they cross here, if this is 5 above the midpoint, this has to be 5. If this is 10, this has to be 10. And we'll do examples of these, but these are the foundational rules that you need to know. Okay, next. And now that we have this information, we're going to use these to kind of help us to solve each of the problems on this page. So when I look here, it wants us to know what's the question mark. So they gave us 135. What types of angles are angle R and angle T? Are they opposite or consecutive? Some people say consecutive, some people say opposite. They are opposite.
Yeah, they are.
In order for them to be consecutive, they have to be touching the same side. So we know that these angles are opposite. And because these angles are opposite, we know that for number 2, they're congruent, which means they're equal. So the question mark is equal to 135 degrees. Ma'am.
So the consecutive angles would be like on number 2 would be like even.
Exactly.
Oh, okay.
And in number 2, we are trying to find this question mark. So see how they touch the same side? Remember, because consecutive interior, same side interior. So because these 2 touch the same side, we know that because of number 3, they have to equal 180 degrees.
So we write all this down? Which is parallelograms?
I would write it down. Okay, or since you didn't put your phone away, you could take a picture. And Nayla, we're also recording this, so you could watch it later. So if we subtract 70 from both sides, we're left with 110 degrees. Okay. Now, number 3, it wants to know letter V. What type of angles are V and U?
They're consecutive.
They're
Wait, but doesn't the whole parallelogram have to equal to
the whole parallelogram equals 360 because technically speaking, there's two triangles in it. And one triangle is 180 plus the other triangle is 180, which gives you 360 degrees. So every four-sided figure will have 360 degrees for their total angles. So these are consecutive. So because they're consecutive, we know because of number 3, they have to equal 180. So if I have question mark plus 80 equals 180, subtract the 80 from both sides, question mark equals 100. Except I'm writing it as 110. So opposite is like you have to go on a journey across the park. Same side as you're touching the same line. Okay. So number 4, same idea. Here we'd have to walk across the park. We'd have to walk across the parallelogram park. So because we're walking across it, we know that it's opposite. Because of number 2, we know that opposite angles are equal. So our question mark equals 98 degrees. Anyone need clarification on angle measures in a parallelogram? Yes, ma'am. Yep, number 3. Because these are touching, if I trace this line, because both of these angles are touching the same line, they're called consecutive or same side. So when that happens, I find out that they're equal to 180 degrees. If I go up here and I draw my line here, because the 135 is touching the green line, but the question mark is not touching the green line, they're not same side. They're opposite. So that means that these two are equal. But if they touch the same side, that means they equal 180.
So this number 2 is the same thing. It's just
number 2 is the same thing. It's just on the side. If I draw that line, both angles are touching the same line. So because both angles touch the same line, I know it has to equal 180. But if I go down for like number 4 and I draw the line, they're not touching the same line. So because they're not touching the same line, I know they have to be equal. Okay. All right, let's move down to the next set of problems. For this one, we're looking at the sides of a parallelogram. Our first thing is opposite sides are equal. You can't do anything with consecutive sides. I mean, technically speaking, you can down the road if you have the diagonal. But for our purposes, you can't do anything with consecutive sides, ma'am.
So the top and the bottom, they still count as consecutive sides if they're both on that.
If they both touch the same line, they're still consecutive. Yep. Good question. So here, for number 5, we know by number 1, opposite sides are equal. So if this is 23, how long is SP?
23.
23. Literally that simple.
Now it's about to get hard in 7.
It'll get hard in 7. For 6, if this is 12.6, the opposite side has to be 12.6. And the reason is number 1, opposite sides are congruent. And you don't have to write the reasons down. I'm writing them because if you do have to do a proof, and there are proofs on your test, there's parallelogram proofs, you'll need to say opposite sides are equal or opposite angles are congruent. And you'll see that when we get to the further on in the packet. Like I think page 13. Ma'am.
That's because number 3 is a consecutive. You said it right.
Correct. Okay. Now this is where it gets a little bit more challenging. Number 7. It tells us that RT is 19.8. And that's going to relate to our 5th thing that we wrote about, which is diagonals bisect each other. So if this is 19.8, that means that the other part of this line also has to be 19.8. So if it wants us to know this entire length, it wants us to find RP. Here's R, here's P. If it wants us to find this whole thing, all we're going to do is do what with those two numbers? Add. Thank you for not saying multiply. So you can use a calculator. There's calculators in the back. Oh. So 39.6. Can I have someone get me my markers in my middle drawer back there, please? That way I don't have to use a dry erase marker.
Where?
Thank you, P2. In the middle drawer of that desk. There should be, I think, a pack of markers in that drawer, in one of those. Yeah. Thank you. Since we're recording it, I'll make sure that y'all can see it more clearly. Appreciate you. Okay, now I'm going to jump down to number 9, but then we'll go back to 8 and 10. Okay? The reason why we're going to number 9 is because number 7 and number 9 are similarly done. And then I'll switch over to what 8 and 10 are asking us. So for number 9, it tells us that Km, which is this entire piece, equals 23.4. It wants us to find Ym, which is just this piece. We divide it. That's right. So because the longer piece is the bigger one, we're going to divide by 2 to get to the smaller one. This is number 9. Yes, because of number 5. Excellent job. You were ahead of my brain. 23, is that 17.2? Oh, wow. Good thing I have fact checkers. 11.7. Okay, so main thing to remember here, and you will have a question on your test, is that when you do the bisecting, just make sure if it's small to big, you're going to multiply by 2. If it's big to small, you're going to divide by 2. Okay? You could also think of the formula like 2x equals the longer one, but I just think small to big, it gets bigger, so you're going to multiply. Big to small, it gets smaller, so you're going to divide. Okay? All right, let's look at number 8. For number 8, this is where it gets a little tricky. I want you to look at a couple things. You are looking for the hidden parallel lines, and you're looking for the hidden triangle. So it tells us we're trying to get this angle right here. That angle is hidden inside this triangle. But in order for us to get that triangle, we have to know our third angle. Because how many degrees are in a triangle? 180. It doesn't say isosceles. So we can't say base angles are the same. P2, you guys good?
We're excellent.
Okay, so now because of that, watch where the hidden parallel lines are. Right here. So now we can have, I'm actually going to turn it on its side so it's more easy to see. If this measure right here is 52, how many degrees is the other measure? 52. Why is this 52? What kind of angles are those?
Alternate interior.
Brilliance, alternate interior. So if this is 52, this right here has to be 52. So now that I have these two, I know a triangle has 180 degrees, so I can do 180 minus the 60, which gives me 120, minus that 52, which was already shared, gives us 68.
Go on there, Jen.
Okay, is that what y'all got?
Wait a minute.
Wait a
minute. Did you put 52 or 30?
52. Yes, ma'am. How'd you do it?
I did 60 plus 52. Yeah, that's fine. Minus 180.
You can also do it that way. Because, and I'll show you down here, that's a good way to do it. Kennedy noticed that this right here, these angles are consecutive angles. So because they're consecutive angles, they equal 180 degrees. So we know that all 3 of those pieces have to equal 180 because in a parallelogram, consecutive angles equal 180 degrees. So then I could combine 62 plus 55 is 117. Subtract 117 from both sides and get 63. So you can do it either way. What else can I clarify on this page?
Wait a minute.
Ma'am.
So basically, wait. So you see what the triangle, the question mark is, right? In the bottom.
Yes, ma'am.
Okay. The question mark right there. And the 55 is over here. So does that mean like you never painted to the second triangle, but like the triangle BDC?
Yep.
That means 62 would be the degree angle right there up in the corner between the B and C.
Yes, ma'am.
So that means I just add them two together.
Yep.
And I do 180.
You can do it that way. Yep.
Oh.
Good job.
Is it because of number 3?
That's because of number 8. Oh, it's because of, yes, number 3.
Boy, you have a lot of
Yep, the reason is number 3. We good? Now we're going to go to the challenging one. Yay! Flip the page.
Yeah. Okay, that was
You gotta have a group.
Ma'am. What number? After we finish the parallelogram, both sides, we can take a break. Can I flip? I'm sorry? Okay, I'm flipping. Next page. Okay, so if we look at these measures, now the good news is they only want you to find X. The bad news is, thank you for putting your cell phones away. The bad news is that on your test, they probably want you to find the angle measures. So we're going to stop at X, but then to get the angle measures, you'll have to plug X into the angles to get the value. And I'll demonstrate that once or twice. So here, if we need to figure out X, these are the two angles they give us. What kind of angles are Z and Y? Consecutive or opposite? Opposite or consecutive? Consecutive. So because they're consecutive, what do they equal? 180. So we'll do 11x minus 10 plus 80 equals 180. Now, in real life, I probably would have just written down 11x plus 70 equals 180. Yeah, yes, ma'am.
If you just asking for x, wouldn't you do 11x minus 10 equals 80 because they're consecutive? So that
nope. If they were opposite, they are equal to each other. Consecutive equals 180. Okay.
Equals 3 equal to 360.
Because if we had these two here, then it would be 360. I mean, we could do 80 plus 11x minus 10 plus 80 plus 11x minus 10 equals 360. Okay. So now we're going to combine these. 11x minus or plus 70 equals 180. Yep. Subtract 70 from both sides.
I remember doing this last year.
Divide both sides by 11. Yep. X equals 10. Hopefully this part you already know, right? The new thing is connecting it to geometry. But you should already know how to solve two-step equations.
Yes, I already here. Tell us what I was saying.
Where we at?
Okay. Now, this next problem is kind of tricky.
Is it saying that for the line or for the angle?
The line.
Oh, because it was too far down.
So it's saying that this side is 2x plus 15.
So they're equal.
And yeah, and this side is the other side, x plus 15. So we did here they're equal. Now, usually speaking, I like to move my x's first. But I found kids are getting confused when I move the x first, so this time I'm going to move the 15. So I'm going to subtract 15 from both sides. When I do that, I get 2x equals, oh, well, this is the harder way.
So number 11
2x equals x.
Our 11 is what?
11 is consecutive, 12 is equal.
Yeah, you know.
Because these are opposite sides and opposite sides are equal. Yep.
Why don't you just subtract x?
I can. I'm going to show you that one next. That's what I should have done. Now here, I'm going to subtract x from both sides. X minus x is 0. 2x minus 1x is x. So I'm left with x equals 0.
So.
Now, some kids got confused with that. So what you could have done is if you have 2x plus 15 equals x plus 15, I could have started off by subtracting x from both sides and then subtracting 15 from both sides. Either way, you'll get x equals 0. And it makes sense, because if I put 0 here, 2 times 0 is 0. 0 plus 15 is 15.
So
0 plus 15 is 15.
you said it says 2x equals, so that says 0, the x stands for 0, right?
Yep. So far, so good. Next one.
Aren't you actually supposed to divide, not like trying to?
You would divide if there was a coefficient, but there's no coefficient, so you're subtracting.
Is it the coefficient?
From which one? Here?
Yeah.
We're subtracting because there's x's on both sides. If there was only an x on one side, then we divide.
Oh, I get what you're saying.
Okay. All right. Are these consecutive or opposite? Consecutive. So consecutive means what? 180. They equal 180. You know what it is? Is the button to do the handicap door is on this side.
You gotta bang it that hard?
So they bang it to open the door because they feel if you bang it, it's going to open it faster.
I be thinking that too.
Well, it's not true. Now you know. I mean, if you hit it too lightly and you don't press it in, but ma'am. It's okay. Start with 17. What was your question? Nope. In 17, you're going to have to find FU first, and then you can do, or UF first, and then you can set them equal. Because UH is this piece right here, and FH is this whole thing.
Won't it be equal to each other? UH and
Yes. UH and UF are equal to each other.
Isn't that the definition of bisection?
Yep. Diagonals bisect each other. All right. So right here, we're going to combine 9x and 6x is 15x. 15 plus 5 is, 15 plus 15. There should be a 15 here. I miswrote it.
You must be proud of it.
30. Subtract 30 from both sides. 15x equals 150. Divide by 15. X equals 10. And you know what? In the last class, we didn't do 15 or 16 because it was too easy. So we'll cross those out. All right, 14. Let's do 14 and then we'll jump down to 17. Okay, are the angles in 14? Are they opposite or consecutive? They are consecutive, same side, 14. So because they're same side, what does that mean? They do what? They equal 180. Combine like terms. Subtract. Divide. On a scale of 1 to 5, 5 is like you got it, 1 is you don't have it. Where are we at these types of problems?
4 and 3.
4, 3, 5s, 4s. Okay. Fantastic. Okay, now we're going to move to diagonals. Ma'am.
She was in my class. He was our teacher in 7th grade. We had the same class.
Y'all are recording your conversation, I'm just saying. I mean, I don't know how much they can hear, but like, it's still recorded. Okay, I need to go on. Okay, you'll have to watch the video. Next. The question that we talked about before is, does UH just equal FH? Here it tells us that UH is 19, and it tells us FH, which is the whole thing, is 5x minus 7. Please stop talking. Please stop talking. So all we need to do is we need to find out how much this piece is, UF, which is how much if the diagonals bisect each other.
What's it called? 38.
The whole thing is 38. This is 19. Yep. So this whole thing will end up being 38 because 19 times 2 is 38. So then we just do the math. 5x minus 7 equals 38. Add 7. 5x equals 45. Divide by 5. X equals 9. Again, you should already know how to do multi-step equations. You should have mastered that last year in algebra. Because this is 19, diagonals bisect each other, it means both of these have to be 19. 19 plus 19 is 38. Okay, 5 more questions, then you can take a break. I want to just finish this one so I can just stop the parallelogram video. That's the only reason. Guys, let's just do this video as a parallelogram video. So we got 5 questions. Here we have KU. KU is this piece right here. This piece is 3x plus 3. UM, which is this piece right here, is 4x minus 4. What do I know about diagonals of a parallelogram? They do what? Bisect each other. So that means that each of these pieces are equal, congruent. Yep. So 3x plus 3 equals 4x minus 4. Now, I know I do this differently than your teachers did last year. I always like to keep my x's positive because I don't like dividing by negatives. So I move my smaller x. So I'm going to move 3x to both sides. 3 equals x minus 7. Oh, minus 4. Add 4 to both sides. X equals 7. Now, some of your teachers said subtract 4x from both sides, and then you would get negative x equals negative 7, and then you'd have to divide by negative 1.
Okay.
What? So here, I started by subtracting 3x from both sides. I chose to subtract 3x because I wanted to keep my x positive. 4x minus 3x is 1x.
That looks like a 4.
This looks like a 4?
No. The next one.
And then this negative 4 came down.
Oh, okay.
And then I added 4 to both sides so that these cancel. And I was left with x equals 7. Yes, ma'am. All right, bottom 2, we're almost there.
Yo, this is actually making sense.
Yay! Next. Say that again.
This is square. What is parallelogram?
Remember, every square is a parallelogram. It's like the parallelogram is the grandfather. And the rhombus and rectangle would be the parents. Good question. So this is a rectangle, but remember, rectangles are still parallelograms because the rectangle is just a parallelogram with a right angle. So because of it, we know our opposite sides are equal. -1 plus 4x equals 3x plus 3. I'm going to move the 3x so that I can keep my x's positive. Add 1 to both sides. X equals 4.
Oh, wait a minute. So on a pair, you know.